Hey everyone, it's Justin again. In this lesson, we're going to take the distance formula up a notch, and you will need an algebra skill called simplifying square roots for this lesson. There are some directions in your notes template for how to review before beginning this video. If you haven't worked through the review already, pause the video and do that now. By the end of this lesson, you should be able to find the distance between 2 points as a simplified radical and decimal approximation. First, we'll discuss the differences between Pythagorean triples and other right triangles. Then, we'll complete 2 examples. So far, when we found the distance between 2 points, we've only gotten whole number answers. That's because we've only been working with Pythagorean triples. The distances between the 2 points always ended up being a whole number. And if we made a triangle, the lengths of the legs were whole numbers too. These are all Pythagorean triples. But honestly, most right triangles don't have a hypotenuse that is this nice. And most distances aren't this nice either. Most of the time, even if the legs of a right triangle are whole numbers, the hypotenuse won't be. These are the kinds of distances that we're going to find in this lesson. And we're going to learn to write our answers as a simplified radical and as a decimal approximation. So let's give it a try. Use the distance formula to find the distance between the 2 points listed here. Then, write your answer 3 ways. The first way is as a simplified radical, which will just mean a simplified square root. Also, try writing your answer as a decimal approximation to the hundredths place and to the tenths place. Pause the video now and see how far you can get on your own. Were you able to substitute the numbers in correctly to match one of these? If not, make sure you labeled your points either like this, with x2, y2 first and x1, y1 second, or the other way around, like this, with x1, y1, and then x2, y2. Pause the video now if you need time to check your work and make any changes. Both of these can be simplified using addition or subtraction. And once we square the terms in the parentheses, they both end up here. In our previous lesson, we would have taken the square root of this and gotten a whole number. But this particular square root doesn't give us a whole number. We need to see if we can pull out any doubles to simplify the radical further. When we factor this as far as possible, it's called finding the prime factorization. And we have that here. Then, we group any pairs together so we can take their square root. The square root of 2 times 2 is 2. And any numbers that didn't have a pair can get multiplied back together, like the extra 2 and the 17. Those multiply to be 34. This is called the simplified radical. And it's the most accurate way to write our answer because we're not rounding. We can also type 2 times the square root of 34 into our calculator to get a decimal approximation. Pause the video here and type this into your calculator now. You should be getting something like this. And know that even this has already been rounded by your calculator because it really goes on forever. Let's practice rounding to the hundredths place by looking at the number in the thousandths place. The 1 in the thousandths place is less than 5, which means we should round down and keep the 6 in the hundredths place, giving us 11.66. This isn't as accurate as our previous answer. It can be easier for others to understand since we all basically know how big 11.66 is, but it's harder to approximate how big 2 times the square root of 34 is in our heads. Then, let's round to the tenths place. Since the number in the hundredths place is 5 or higher, we'll round the number in the tenths place up to 7, giving us 11.7 as our approximation. This gives us all 3 ways that you may be asked to write your answer in the practice problems. Be sure to read the directions carefully when you do your practice problems so you know what's expected of you. And if we really wanted to see what's happening on a graph for this problem, we could sketch in a right triangle connecting these 2 points and label the lengths of the legs. Then we can visually see that around 11.7 does seem like a reasonable length for this hypotenuse, or the distance between the 2 points. At this point in our learning, I'm not expecting you to keep drawing these pictures, but I did want to show you one more time what it means to find the distance and how to make sure your answer seems reasonable. Let's do one more example before you work on your practice problems. Find the distance between the points listed here and write your answer all 3 ways. Pause the video now, take all the time you need to do this. Did you get one of these setups? Did you get the square root of 125? While the square root of 125 is correct, it's not how we're asked to write our answer. So let's keep going. We can write the prime factorization of 125, group any pairs together, and then take their square root. This gives us the simplified radical and one of our answers. Then we can use our calculator to find a decimal approximation and round to the nearest hundredths place and tenths place. These are the other 2 parts of our answer. In your practice problems, you'll only be asked to find one of these 3 types of answers per question. So be sure to pay close attention to which of these 3 you're being asked to find. Now you can find the distance between 2 points as a simplified radical and as a decimal approximation. It's your turn to get lots of practice in. It's been fun, and I'll see you later. Hey.